Hello students, welcome to my channel Infinity Minds where maths is made easy. Today I thought of putting up a short video in order to revise all the identities that we have learned in our top chapter number 4 exploring algebraic identities so that you can revise them quickly before your tests or exams and do well. Okay, so let's go through. Yes, all the identities have been put up at once, so that you can take a screenshot of this, children, and keep it with you and practice it, revise when you're solving questions. You can refer to them so that it helps you in learning also. Okay, let us just quickly go through them. Identity number 1, x plus y whole square, which is x square plus y square plus 2xy, square of the first term, square of the second term, plus the twice the product of the two terms. Next, x minus y whole square, square of the first term, square of the second term, minus twice the product of the two terms. The way there is a plus in the first one, the same plus 2xy gets replaced by the minus. If there is a plus, you will be putting a plus here. If there is a minus, you will be putting a minus here. Rest of them remain same in the first two, okay, regarding the first two. Whatever I am annotating, I shall erase towards the end, then you can take a screenshot. Property identity number 3, x plus y plus z whole square. All of these have been explained in details during my previous videos. You must refer to them if you haven't. So I had explained as to how we get x plus y plus z whole square when you have sum of square of sum of 3 terms. Say you could replace one of them. If I replace my x by another 2 terms, and that is how we had devised this. So what you get is individual squares of each of the terms, x square plus y square plus z square. It is a plus, so everything is going to be plus simply, okay? So x square plus y square plus z square is little similar to this only. It is an extension to this basically. Like you had 2xy. So here also it would be twice xy. But then it would be twice of y and z also. And then z and x also. As we will be forming combinations of the first with the second, second with the third, third with the first. Children, you know best and easiest ways if you go in an order. You can do it in any of the ways. Of course, it is addition. So changing the order will not matter. But it is best suggested like the of 3 terms that you are having. So go make your product also in an order. First with the second, second with the third, third, only to avoid errors, nothing else. Okay. Now in this one, if you get a minus, any of these, say you are having a minus, so it is not to be taken as a minus. Since our identity we only have plus with us, we shall be treating minus as an addition of a minus y. Okay, we shall be taking it as adding a minus y. Your value of y gets replaced by minus y. It becomes the square of a minus y, which would be positive y square only. And here it becomes a minus 2xy automatically. Not that you need to devise another identity, but the value that you would be having will give you this. Depends on the value. If it's x is positive, maybe or x also becomes negative, then all such questions we had done. We had practiced in our previous exercises and videos. Minus into a minus shall become a positive, because it depends on so many combinations. 2 can be negative, 1 positive, 2 negative. So we can't have identity for each and every thing. Here we made an identity because it is still possible. I mean, there are only 2 choices. To be honest, okay, let me change the color of the pen because it's creating, even green won't do. I think this one should be fine. Even this one, the negative, if you see, identity number 2 is straight away this. If somebody doesn't want to use identity number 2, it is absolutely fine. You can have the same identity number 1 with value of y as negative. It is very much x added to a negative y. Okay, yes, this is also same. But there we have formed 2 identities. This you've done in class 8, that okay, there were only 1 or 2, 3, so they were made. But now with 3 terms, if so many possible combinations, So it is not advisable. The more you learn, more chances are there for you to make an error. And it is smart, wise enough, you've learned how to handle situations. So as per the value, you make that value of y or z or x, whatever is the need, to be negative and handle accordingly. So this one you learn, and rest you adjust the signs. Clear? Let's go to the fourth one. X plus y into x minus y, when same two terms are added or subtracted, x square minus y square. X plus a into x plus b, x square plus a plus b times x plus ab. Ax plus b bracket cx plus d. This is kind of your extension to this only. It is based on this. This itself is based on your first identity, square of the first term, square of the second you are doing. Okay, plus twice the product is what is happening. Since the terms are such, so you are getting such value. But yes, we do have them ready-made so that it is faster for us. So this shall become, see, it's bracket opening ACX, A into C and x square. The terms with x shall become ADX plus BCX. So we shall have AD plus BC in brackets plus BD. Okay, this is of course uncommon. There's hardly one question or so on this. Coming to these, yes. Now these are the ones based on cubics, the new, more of class 9 level, the new ones that have got introduced to. Even this one was introduced at class 9. So cubic, yes, it does become little confusing. Especially 7, 8 are related to 9 and 10. Whatever with the plus and the minus, or probably I can say the plus with the plus, 8th is related to 9th and 7th related to 10th with the minus. Okay, that x cube minus y cube and this x minus y whole cube. This is what I'm trying to say. 7th and the 10th, 8th and the 9th go hand in hand. Okay, let's see. X cube minus y cube, x minus y brackets x square plus y square plus xy. Now from then x cube plus y cube, you get an x plus y bracket x square plus y square minus xy. Step number 1, how to remember. If it's a minus, the first bracket would carry the same, minus with the minus, plus with the plus. That is the, I mean, these are just tricks to remember. If it's negative cubic value, that identity that is asked, the minus will come minus. If there is a minus here, it is going to be a plus here. The plus shall follow the plus, and the second one would be a minus. You getting the difference how I'm telling about that? See, if you have a negative, the first is going to be the same sign. So after that, it's all going to be positive. If you have a positive, first will be positive. Just a trick to remember. First will be positive, and after that, this particular term will be negative, because x square and y square are anyway supposed to be positive only. Difference is only of these. These matter. Minus with the minus, second will be positive. Positive with the positive, second will be negative. Okay. Now coming to property number 9 and 10. X cube plus x plus y whole cube. X plus y whole cube. Cube of the first term, cube of the second term. X cube plus y cube plus 3x square y plus 3y square x. This was the one I have been telling, that in these two there is a different way to write. We could also take the 3xy common, and in brackets we can have x plus y. Like x cube plus y cube plus 3xy is common, and inside you have an x plus y. So both the forms are same, depends. Like in one of the previous questions, this was the one that is applicable because the value of x plus y was given. So which form you utilize is up to you. This one is the best. You can always take common and have that one with you. The less you learn, less chances to forget. That's your way of recognizing things. It's your way of looking at, it's your perspective. So at least I don't emphasize whatever essential. Of course, you have to learn, children. Which are things which are avoidable, it's up to you. How you see to it. If you require, you can learn, then it is best. And if you can manage handling at that time, that is also equally advisable. Okay. So x minus y whole cube, x cube minus y cube. This one, I'll be very honest, 10th one slightly you need to remember. There's not much trick to remember. Of course, the first one, x cube and y cube will be minus, it's a minus. After that, you have to kind of learn this. Minus 3x square y plus 3y square x, okay? This one, slightly. Because this is very simple, all are going to be positive. And x cube and y cube would be carry a minus, that is fine. But this one you need to remember in a way, minus 3x square y plus 3y square x. Okay, coming to one last, and yes, it's pretty lengthy also. X cube plus y cube plus z cube minus 3xyz minus 3xyz will be x plus y plus z bracket x square plus y square plus z square minus x square minus yz minus zx. Learn it, write, practice writing each of these identities. You can look at this chart, copy down, not a problem. But then keep practicing. Write them down 2 times, 3 times. Then you will be able to learn. In this, a particular case is in the last identity, children, with x plus y plus z equals to 0. If this thing is given, this is equal to 0. So this LHS becomes equal to 0, and in that case, x cube plus y cube plus z cubes becomes equal to 3xy. That is a particular case of x plus y plus z becoming equal to 0. That is again, if the situation is given, you can put it equal to 0. Then that's like a sub part of this sub identity that you can create. If this comes 0, then obviously this thing becomes equal to 3xy z. Okay. So please take a screenshot and let us go ahead, or you could pause the video later, replay it again, pause it and do it. Okay. So yes, we can just have one last summary points, few of them. I'll just quickly glance through. You will be able to understand all of them. Point number 1, identities are equations that are true for all values of the variable. This was the first thing we began my part 1 video started up with. So this is like one of the identities. What we are trying to say that this is an identity which is written. It is true for all values of the variables. It was in contrast to an equation solving. If your equation solving is there, variable is A, it will only be true for a specific value. The equations that you've been solving, it was in comparison to equations. That equation also carries an is equal to, this is also is equal to, so there was comparison of this thing which was done. Equation is true for a particular value of the variable. On the contrary, identities are true for all values of the variable. I think that is very simple and clear for us to understand. Let's proceed. Point number 2. One of the ways to visualize identities is using geometrical models or algebraic tiles. Algebra tiles, these are with your activity pool. Different color sheets when you use. Okay, I'll try and put some activities also. Maybe in a few days time, you can expect an activity coming up in one of my videos. Point number 3, identities can also be used to factor algebraic expressions. All these have been discussed in your Ganita Manjari only. Okay. So the factored form a square minus b square is a minus b into a plus b. Of course, that's an identity. Like you're splitting of middle term, you're making factors of a given expression. So see, this is an expression containing 2 terms. When you put it as product of 2, so you have done the factored form. You have made factors of it. Point number 4, factorization of quadratic expression may be visualized by means of algebra tiles. Let us quickly, this also I had taken up in my first video. X square plus 5x plus 6, of course we solve it with our usual splitting middle term. Factors of 6, 2 and 3 added gives me 2 plus 3. We have certain steps in between, taking common and all. So it is a trinomial. It has been broken up as product of 2 expressions, and we do it through splitting middle term method. Diagrammatically, if you see, if there is a tile which is x comma x, okay, you will say a square tile. Yes, a square is a rectangle, not a problem. Okay, x cross x is an x square tile. Now if this is x and this is 3 units, so product of the sides, area, children, area becomes 3x. Here the area shall become 2 cross x, 2x, and here the area would be 2 cross 3, 6. So if it is a rectangular slide, whatever, grid of length equal to x plus 3 and breadth is equal to x plus 2. So x plus 3 into x plus 2 product length into breadth gives me the area. Area is x squared. 3x plus 2x is my 5x plus 6. So visually we have done this. Quadratic expression we have broken into factors. All of this has been explained here. Okay. Coming to point number 5, identities can also be used to simplify calculations such as squaring numbers or evaluating product of numbers. Like if you have to find square of a number 97, so many questions we have done of this type in this chapter, no? So expressing it as 100 minus 3, nearest, round it off to a nearest whole number, power of 10 preferably, getting zeros, 100 minus 3. So now using a minus b whole square identity in this case. And many a times we used to do a plus b also depending. Say if it was say 102 square, we would have preferred doing with 100 plus 2 whole square. Then a plus b whole square would have been used. So it would be square of the first, square of the second, minus twice the product. Another example could be expressing 9 as 10 minus 1, 10 plus 1, 11. A square minus b square has been used, right? Okay, so point number 6, rational algebraic expressions may be simplified by factorization and removing the common factors in the numerator and denominator provided such a factor exists and is not equal to 0. This is, in simple words, division of your expressions that is being talked about. Okay, how are we required to divide any two expressions of polynomials? By breaking them up into factors and cancelling the common factors. So that is what is being referred to as rational expression. That is being referred rational in the form of P by Q. It's pretty tricky to understand this. So it is basically division of expression in simpler mathematical words if we say. So x square minus 9 will be utilized done with a square minus b square identity, x minus 3 into x plus 3. So the common factor x minus 3 cancels and we are left with x plus 3. X not equal to 0, yes, that is something which is always mentioned. X not equal to 0, denominator non-zero. Tell me why? Because division by 0 is not possible. Division by 0 is not possible? Yes, of course. That is like a rule that is always true. Even in a definition of rational numbers, that is always true. Okay, so I hope the entire chapter has been summarized well. Now you need to practice and make yourself perfect. So keep watching. Do like and subscribe to my channel. Okay, thank you and keep practicing. Do well.